Well, hello, and welcome back. I'm AJ O'Neill, and I'll be your instructor for tonight's Beyond Code session. So, tonight we are going to talk about the difference between floats and ints. I'm not going to go too deep, just going to be a little bit of story time and a few examples. So, I'm going to go ahead and just get started. In any programming language, I've got a node console open up here, but that's not important what programming language it is. In any programming language, when you add 0.1 plus 0.2, you're not going to get 0.3. You're going to get a number that's pretty close to 0.3, but not 0.3. And I'm going to start with a story of why this was particularly important. So, oftentimes we put things on a scale between 0 and 1, such as transparency. So, anything that can be measured as a percentages. Transparency of an image or a video, volume. There's a variety of different cases in which you'd use this, but it's pretty common to set something, and I'm just going to type out here as an example, volume equals 0.75. So that doesn't actually mean anything. I just am typing on the screen. Okay. So the problem comes if you think, okay, I want to decrement the volume, say, by 10%. So let's say that the volume starts at 1. This is what actually happened to me. I was developing an audio application, and I got to a point where my program froze because I was taking volume and I was doing minus equals 0.1 so that I'd reduce it by 10%. And this was the only number that I was using was 0.1 increments. And so I'd reduce it and reduce it and reduce it. And every time the person clicked a button, I'd go down by 0.1. Now, as you can see here, this is very bad math. And when we get really, really close to 0, we get what appears to be a completely random number. So in my program, I had a check. Let me go ahead and clear the screen here. I had a check if volume is, I think it was something like if 0 is equal to volume, and then it had like a pause button. I don't know if I set it to pause or if I changed the volume button to be grayed out, or I don't remember what it was exactly I did, but I had this. And as you just saw, when the volume is close to 0, I wonder if we can go back the other way. This will be interesting to see. If we add 1 each time, will we actually get back to... Okay, we do, interestingly enough. Okay. So the problem was that my program never met the 0 condition because I was using floats and it didn't actually get to 0. And so what I found is that depending on the situation, you may want to, especially if you're dealing with money, you always want to deal in the lowest possible number. So if you're dealing in tenths of a cent, then you'd want to use count in the arena of 1,000, and you always want to round. So if I were to take this, let's say I was we can change the volume in increments of 1,000, thousandth, instead of a tenth or a hundredth. Let's say that we wanted to be able to do 1,000th. At some point, I'm sure that this will fail too. I don't want to get all the way there, but we could do that if we did instead math.round volume times 1,000. That would be, it would be better to figure out what your theoretical maximum is in many cases, not all cases, but figure out what your theoretical maximum is. It doesn't make sense to adjust the volume by increments of 1,000. It makes sense 100. It might make sense to have more than 100. But so we could go exorbitant. We could just say 10,000, and we'll allow everything to work in from 0 to 10,000, and that could be our range. And then we don't have to deal with floats. And then we know that as long as we're using a whole number, we're not using any fractional numbers, we'll always end up with a number that is in the expected range. So that's one way to go about this problem. And another way is that you use floats, because floats can be useful and are sometimes required. The volume API that I was using for the music playing library that I was using, it required the information to be in a float. But what I ended up doing was had a decrement function and an increment function, and it did the conversion inside of it. So it looks something like this, decrement, and then I gave it an integer, we'll call that n, and then, and I did something like this, volume, what was it, equals volume times 1000 minus n, and then I think I had math.round here, something like that, divided by 1000. So this is, it looks a little silly, but what we're doing is saying we could take our volume number, that if it's a float, we can multiply it by 1000 and round it. That's going to give us a whole number with no fidgety bits guaranteed. We could subtract our whole number from it. So say we're subtracting 100 or 10 or whatever increment we're using, and then divide the whole thing by 1000 again is going to get it back to a fractional number. And the reason that we do this, if we do this, is just so that our number always stays in a valid range. So anyway, yeah, if you're dealing with money, you want to make sure that you are either using a scientific library. Often these are called big ints, meaning, or arbitrary precision numbers. So it is possible, even in languages like JavaScript, I think it's just called big int. Yeah, I forget what the symbol for it is. Is it 1b? Is that what it is? No. There's some symbol for it. I'm forgetting what it is, so I'm not going to go into it. But if you need to deal in very large numbers or very small numbers, and you need to be precise, you need to be using one of these tricks. Either use big ints, arbitrary precision numbers, which is just another name for big ints, which allows you to do computations that are slower, but that are exact. They give you exact real numbers, not kind of randomish numbers, or you can do this multiplication and division type of thing. So anyway, that is, I think, really all I wanted to go through tonight. Just kind of give you a little taste of what can go wrong and how to go about it to not have that problem for yourself. So if this was useful for you, please give it a thumbs up. Consider sharing with someone else who might also find it useful. And if you want more like this, go ahead and click subscribe and ring the bell to get personalized recommendations. Also in the description, there are two channels. One is the live stream channel, which if you're watching this live is the channel that you're watching this on right now. Whoops, that's not what I meant to do. And the other is the Beyond Code Bootcamp channel. I am in the wrong window here. I was checking to see if we actually have any live comments. Okay, so yeah, you can check those out in the description, and I will catch you later. Adios.